Hi, I'm Drew, a tutor for mathematics here in Wyzant. I tutor a number of topics, but today we're going to be looking at a problem that was posed, and there's a little bit of linear algebra in here. Wouldn't say this is so much calculus, so this is the problem that we were given here. So we're given 3 points. We're given the point P, which is 3, -2, 7. We're given the point Q, which is 2, 2, and -3. And we're given the point R, which is the point 1, 1, and 2. So what we're asked to do is we're asked to find a point S, find the point S, such that we create an isosceles triangle where this angle SPQ or QPS is a right angle. Oops. Where this angle QPS is a right angle. All right, so the first thing that we need to do in this case is figure out what is necessary in order to create some of these criteria. So first things first, I'm just going to kind of draw, not to scale by any stretch of the imagination, but I'm just going to draw 3 points here. Let's call that P, let's call that Q, let's call that S, oops, R, excuse me, R. And so this is the point 3, -2, 7, that's the point there. So what I'm going to do is I'm trying to find this something right here, this point S, such that when I create this triangle here, these two sides are the same length, and this is a right angle right here. All right. So that means a couple things. It means that what we can do here is, if we know this length here, which we do, then we can figure out this length right here. And so that's what we're going to do first. So the length from P to Q, so this length here, we can find the length by using this here, the square root of the differences squared. So let's see, the differences in x is 1 between P and Q. When you do P minus Q, 1 squared, plus, and the difference between this -4 squared, and then the difference in the z values is 10 squared. Then when we add all of this up, it ends up being 1 plus 16 plus 100, which is 117. So square root of 117, and that is 9 times 13, so that ends up being 3 times the square root of 13. So that's the length of that side. So this length from P to S also has to be 3 times the square root of 13. Now, the other thing is that we want this to be a right angle to this. So a good way to think about this is if we were thinking of these lengths as vectors. So if we imagine that PQ is a vector and PS is a vector, then the magnitudes of those vectors have to be the same, which is this here. And since they're right angles, that must also mean, so let's see, this, we're looking at PQ as a vector. PQ, the dot product of PQ and PS have to be 0. Because when you have the dot product of 2 orthogonal vectors, then that dot product is 0. So we have a couple things here. So PQ, and I'll say that this is equal to the magnitude of PS, and we're imagining that these are vectors. So since we're imagining that these are vectors, let's go ahead and write these out as vectors. So this vector PQ, we kind of already did that here, which is going to be equal to 1, -4, and 10. And then PR, and this is going to become important in a second, is 2, -3, and 5. Now, the reason we need this R, because it seems really random that this R is sitting over here, right? The reason that we need that, I assume, it wasn't stated explicitly in the question, but the reason I think it's there is because if you think about every every vector that's orthogonal to PQ. It's not only this one here, but everything in that plane that shares this. There's an entire plane that's orthogonal to this vector. So we wanted to narrow it down. So the idea, I believe, behind putting R here is that this PS vector is supposed to be lying within the same plane that PQ and R are lying, right? So that's why we're going to put that there. So now that we have an idea here, at least we have a reference in terms of the plane that we need to be in. We have to figure out how to relate that to PS. So in this case here, we're going to let n be a vector. We'll let that equal a comma b comma c, and we'll let this vector be the normal vector to the plane that we're talking about, to this plane that PQ and R inhabit, basically. So by doing that, that means that since this n here is normal to that plane, it's also going to be normal to PS, and that's going to be important for us to figure out what that vector is. So we need to figure out what these values are. So we know that it's normal to both PQ and to PR. So in order to find that out, in order to find out the values here, we can use this kind of identity, if you will, that if you take the cross product of two vectors, you're going to get, the outcome is going to be another vector that's orthogonal to both. So, and since it's orthogonal to both PQ and PR, we're going to set this up so n, this vector n, equals this vector, and we're going to cross it with PR. And in order to do this here, this is the same thing as the determinant of this matrix here, ij and k being the unit vectors and the ij and k directions. And then we're going to do PQ, which we have the points for right here, which is 1, -4, 10, and PR, which we have, which is 2, -3, 5. And when we evaluate that, that ends up being, let's see, I times the determinant of -4, 10, -3, 5. We're using cofactors here, minus j hat times the determinant of 1, 10, 2, and 5. And then lastly, plus k hat times the determinant of 1, -4, 2, and -3. Sorry. All right, so we find the determinant of this. This ends up being -20 plus 30, which ends up being 10 I hat. And then here in 5 minus 20, which is -15 when we're subtracting that, so it's positive 15 j hat. And then lastly, we're doing -3 plus 8, which is a positive 5. So we're doing plus 5 k hat. So that is our vector, 10, 15, and 5. That's our n vector. So now we have everything that we need in order to figure out what PS is. We're going to go to the next board here. So just to remind us, we have a couple of criteria. So we have this vector PQ. When we dot that with PS, it needs to be 0. Because PQ, we were told that that's supposed to be a right angle between PQ and PS. Then the other thing that we know we just saw was that PS also has to be orthogonal to that normal vector, which means that dot product also has to equal 0. And lastly, the magnitude of PQ has to equal the magnitude of PS. So this here, if we go back here, we've already figured out this PQ equal to PS thing because we already have a value for that, so that's fantastic. Now we can just focus on a couple other things. So for instance, in this case, if we're looking at PQ dot PS equals to this, let's look at what, let's call S, let's call this, this point S, X, Y, Z, which means that the vector PS is going to equal the difference between them. So that must mean that we're gonna get 3 minus x, negative 2 minus y, and 7 minus c. So that's what PS equals in this case here. So when we do the dot product of PQ and PS, we end up getting here the dot product of 1, comma, negative 4, comma, 10, dotted with 3 minus x. Oops, it's not supposed to be there. You get it there. Negative 2 minus y. I don't know why I keep putting these things there. And 7 minus c. When you dot those together, it ends up simplifying to, now you could do this, just multiply this. It ends up being 1 times the quantity 3 minus x, and then plus negative 4 times negative 2 minus y, plus 10 times 7 minus c. When you simplify that, it ends up being negative x plus 4y minus 10z equals negative 71. Now, the second one here, similarly, since we found the values for n and we now also have ps, so this is the same thing here, which is 3 minus x, comma, negative 2 minus y, 2 minus y, comma, 7 minus z, and that's dotted with our values for n, which we got were 10, 15, and 5. And so that's the same idea, 10 times 3 minus x, plus 15 times negative 2 minus y, plus 5 times 7 minus z, and that's all equal to 0. Then that gives us, once we simplify everything down from doing, plugging up everything in there, then that gives us 10x plus 15y plus 5z equals 35. And then lastly, this one here, we've already figured that out there, and that is the square root of 3 minus x squared plus negative 2 minus y squared plus 7 minus z squared. That's all under the square root, and that equals 3 times the square root of 13. Now we have 3 equations with 3 variables in here, and so you can use your methods of solving systems of linear equations here. I would suggest, because it's going to be difficult to to subtract things like that, or use linear algebra to solve this necessarily. The best way is to use these 2 equations here to find one of the variables in terms of one of the other ones, and then simplify from there. And then once you have it simplified enough, you can start plugging it in here to get values. And that should be pretty straightforward for you to get that done. But yes, I'm happy to help you further on this if you'd like to contact me. Otherwise, I hope this helps. Thanks.